So now let's talk about problem solving. There's two ways to go about solving problems, one that is slower and more deliberate, and the other that's faster and less deliberate. So the first one involves algorithms. Some problems tend to lend themselves to step-by-step rules. These step-by-step rules are known as algorithms. And as a result, they produce pretty accurate solutions, and they do so time and time again. So an example of that would be utility theory in economics. In utility theory, people compute the expected outcome of choices and select the best likely choice. So the expected outcome is really the usefulness of the outcome times the expected probability of getting that outcome. The problem is that people don't usually make decisions by solving equations. They actually use other methods. People, in fact, show a preference for one solution or another based on how the solution is framed. So, there's other ways to do this, and we'll talk about those in a minute. Some problems are kind of ill-structured. That is, there's no known algorithm for solving the problem. So imagine the problem of trying to affect world peace, for example. There's no specific algorithm for doing that, so we often rely on intuition. In fact, we might not think of certain possible solutions to our problems, and we tend to get stuck in the way of trying to solve the problems. What happens when we get stuck over some period of time is sometimes we have this insight. That is, we find a new way of looking at the problem, and that new way of looking at the problem yields a sudden understanding of how to solve it. In fact, we sort of think about it as an aha moment. Insight itself isn't a sudden process. It feels sudden to us, but it often occurs after we've thought through the problem for quite a while. The other way to solve problems is simply by heuristics, and I've talked about heuristics before, but these heuristics are rules of thumb. They're faster, they require less working memory and information, but they don't necessarily guarantee a solution. In fact, not only can a heuristic fail to find a solution, but they can lead us in the wrong direction sometime. When heuristics lead us in the wrong direction, we often call those biases. Let me give you an example of a heuristic. This is called the availability heuristic. The ease of retrieving memories of events from long-term memory tends to bias our judgments of how frequently the event occurs in real life. So what does that mean? Well, we predict that events that are easy to think about are frequent. For example, in the media often has dramatic reports of things like shark attacks, which makes us think that shark attacks are a lot more common than they really are. But the question is, which is more common, being killed by a shark or by falling airplane parts? It's actually 30 times more likely that you'll be killed by a falling airplane part than by a shark. In fact, after September 11th, more Americans chose to drive than to fly. What ended up happening is the extra traffic increased the automobile fatalities in the next 3 months by about 9%. And in fact, news coverage of air disasters tend to instill in us kind of vivid memories of plane crashes. And we overestimate the probability of those plane crashes simply because they're more available to us. So the air traffic falls off immediately following one air crash, simply because of this availability heuristic. Another heuristic is the representativeness heuristic. People estimate that stimuli which are similar to a prototype are more likely to fit the category than are stimuli which are different than the prototype. So stimuli which seem to match our thinking about that thing tend to be overrepresentative. So for example, Thomas is short, slim, and loves poetry. Is he more likely to be an Ivy League classics professor or a truck driver? Well, if you think about it, he seems more similar to a classics professor. But there's a lot more truck drivers in the world than there are Ivy League classics professors. In fact, the Ivy League only has something like 10 or 12 universities, and there's only a few professors in each one of those classics programs. So it's much more likely that he's going to be a truck driver than a classics professor. But we think that he's a classics professor simply because he matches the prototype of a classics professor, better than a truck driver. Another is the recognition heuristic, an example of a very effective heuristic, which predicts that people will place a higher value on the more easily recognized alternative. So if you have two alternatives, you tend to go with the one that you recognize most. And of course, brand awareness and things like that are really based on this recognition heuristic. There's another heuristic called affect, which of course, as you know, affect refers to emotion. We use emotional responses for each choice to guide our decisions. Basically, we go with a gut reaction as opposed to an algorithm, which we talked about before. It's also affected by our need to avoid regret. Regret is seen as a pretty negative emotion, so we avoid that at almost all costs. By considering ways to explain and justify the reasons for the decisions in advance, people tend to sort of rationalize what we've done after the fact.